Good morning, dear students. So in the previous class, what we were discussing the integrated rate equation, right? Yes. So we have seen the zero order reaction and the first order reaction. So we have seen the integrated rate equation for the zero order and first order reaction. Right. So did you practice both the derivations? Okay. Yes. So is it audible now? Okay, fine. So, so yes, what about others? Did you practice zero and first order reaction? Yes. So did you find any difficulty in deriving the equations? Okay, good, fine. So in the last class, so we have seen the zero order and first order reaction. Okay. So differential rate equations for zero order and first order. So these were the graphs. So these all things we have discussed, right? All the conditions, important points. So all we have discussed about the zero and first order reaction. So today we have to start with what? We have to start with the half-life of reaction. Okay. Before that, let us solve one problem based. Okay, let us see one problem now. So before proceeding further, let us take one problem. So the question is like this. The initial concentration of N2O5 in the following reaction. The reaction is N2O5 gaseous giving you 2NO2 gaseous plus half O2 gaseous was 1.24 into 10 raised to minus 2 mole per liter at 318 Kelvin. Okay. The concentration of N2O5 after 60 minutes was 0.20 into 10 raised to minus 2 mole per liter. Okay. So calculate the rate constant of reaction at 318 Kelvin. Okay. So what all is given? Initial concentration is given and after 60 minutes. Okay. So after this also the concentration is given. Okay. So initial concentration is 1.2. Okay. So what it is R naught. R naught is what? 1.24. That is your initial concentration. It is 10 raised to minus 2 mole per liter. And what is your after 60 minutes? After time, that is after time 60 minutes, the initial concentration has been changed to how much? To 0.20 into 10 raised to minus 2 mole per liter. Okay. What is the time? Time is 60 minutes. Can you tell me, so what type of order it is? What is the order of the reaction? Yes. So how you can decide the order of the reaction? So you can see the, yes, what is the order of the reaction here? The order of the reaction depends on what? Yes, order of the reaction. You have to see the concentration of the reactant. It is raised to 1. So here, when you see this reaction, okay, when you see this particular reaction, N2O5 giving you this, so it is the order is first order reaction. Yes, it is a first order reaction. So let us apply the formula. So the formula is K is equals to, okay, K is equals to 2.303 by T log of R naught by concentration of R. Okay, let us put the values. Let us substitute the values. So 2.3035, what is the time is 60 log of what is R naught? 1.24 into 10 raised to minus 2. And what is R? It is 0.20 into 10 raised to minus 2. Okay, solve this and see what you are going to get. Yes, what you have got, just see. So 2.303 by 60. So 1 by 24. Okay. Hmm, okay. 1.24 divided by 0.20. So it will be log of 6.2. Okay, it is log of 6.2 because this and this get cancels. So log of 1.24 divided by 2.6, 0.20, it comes to 6.2. It comes to 6.2. Okay, so this is how much we have. What is log of 6.2? So log of 6.2 is, so log of 6.2 is 0.7923. Okay, and 2.303. Okay, 2.303 divided by 60 is how much? It is 0.0383. Okay, so this into this, how much it is? Just see how much you're getting. So 0.7923. So I have got the rate constant value as 0.030. What is a unit? It is per minute. Yes. Everybody else has got the same. What is your answers? Yes, 0.0330. Yes, VB has got it as 0.030. Okay. What about others? Yes. Okay. Lubna has also got it. Okay. Shri Varuni has also got it. Very good. Fine. Okay, so understood. Okay, so depending on, so the equation will be given. Okay, so initial concentration after time 60, okay, minutes, what was the concentration changed to, that is given. So by applying, by seeing what particular reaction it is, whether it is a zero order, first order, second order, you have to apply the formula and you have to solve the problem. Okay, so this is the way. So these questions from chemical kinetics, you will be getting the problems. Okay, problems are important from this part also. So the problems will be for 2 marks. 3 marks, sorry. Problems will be for 2 marks, 2 marks. Okay. Here, for the formula, 1 mark. Okay. And for the substitution with the correct answer, 1 more mark. Okay. So either the problem will be 2 marks or it will be 3 marks. Okay. So, but this particular problem will be for 2 mark. Why? Because 1 mark is for the formula and another mark is for the complete substitution with the correct answer. Got it? Okay, fine. So like this, the problems will be asked. So shall we proceed for the next thing? Yes. So like this, so some extra questions we will solve at the end. Okay, based on the zero order and first order reaction. So I've just given this one example. Okay, so how the questions are asked. Fine. So now let us start with half-life of reaction. Okay, half-life of reaction. So what is the half-life of reaction? So half-life of reaction, half-life of reaction, okay, that is T half or T 50%. Okay, T half or T 50%, half life. So what is this half life? Okay, what is the meaning of half life? So half-life of reaction is what? It is a time in which the concentration of the reactant is reduced to half of its initial concentration. Okay, so what we are doing in half-life of reaction, so whatever the time, okay, time, so the time is there, okay, it is a time in which the concentration of the reactant is reduced to half. So time in which the concentration of the reactant is reduced to half of its initial concentration, that is called as T half. What it is called as? It is called as the T half of the reaction. Got it? Okay. So this is the T half of the reaction. So you can note it down. Okay, you can note it down. Okay, so what is T half of the reaction? It is the time in which the concentration of the reactant is reduced. Okay, I'll write the definition. So it is the time in which the of the reactant, concentration of the reactant is reduced, to half of its initial concentration, half of its initial concentration. Okay, so this is about the half-life of the reaction. So this is about the half-life of the reaction. Okay. So half-life, so we are going to discuss about the half-life, how it is half-life period is given for zero order, first order. Okay. So first we will see how the expression it is given for zero order. So let us consider the case one. Okay. Case one. So half-life period for zero order, for zero order reaction. Okay, so what is the rate constant for zero order? Yes, how it is given? So K is equals to R naught. What is the formula? R naught, concentration of R by T. Okay, K is equals to R naught minus concentration of R by T. So at time T, that is T, if T is half, okay. So if we take as time, that is T is, so if we cut down the time, okay. So if we do half the time, so what will happen to the concentration? Concentration will be also R naught by half, R naught by 2. Okay. So it will be, so the after concentration. So what is the, so if we are reducing the initial concentration, so concentration of the reactant, what we are doing, we are reducing to half of its initial concentration. Okay. So we are going to reduce the concentration. How? So concentration of R will be R naught by 2. Now what is the next step? Whatever the we are applying the condition, that should be substituted in the above formula. Okay, it should be substituted in the above formula. So let us see. So K is equals to, what is R naught? R naught is R naught only. Okay. So what we have taken R. So concentration of R is reduced to half. So the concentration of the reactant is reduced to half of its initial concentration. So that is R naught by 2. Okay, R naught by half. That is R naught by 2. So this is about the first step. Okay, divided by what is time? Time is T half. Time is T half. Okay, so after rearranging this, what we will get? Okay, K is equals to, so if I take this common, okay, 2. So ones are, so this will be R naught here. So it will be R naught, okay, divided by 2 into T half. 2 into T half. So if I take this T half here, okay, if I transfer this T half here, so we are finding what? We are finding the half-life. So half-life can be found out by, so what I'm doing, I'm taking the T half on the other side. Okay, so it will be R naught by 2K. R naught by 2K. So what I'm doing, T half, I've transferred here. So K will come down, right, to the denominator. So like this, I'm going to take, so find out the half-life of the zero order reaction. Is it clear? Yes, did you get it? So let me explain it once more. Let me take a blank slide only. You don't get confused. Okay. So what are the steps? So we are considering the half-life period for zero order reaction. So what is half-life? It is a time in which the concentration of the reactant is reduced to half of its initial concentration. So what are the conditions to be applied? The conditions are that time, okay, the time is considered, the time is taken to be t half. Okay, so we are applying. So at time that is t is equals to t half. Okay, t is equals to half. Okay, t half, and R, the reactant will be reduced to its initial concentration, that is R naught by 2. Okay, so rate constant is equals to R naught minus R naught by 2. Okay, we are taking the initial concentration divided by T half. So rate constant. Okay, so just rearranging, we are just rearranging the things. Okay, and we get the T half for zero order will be R naught by K. Okay, so this is the formula for zero order reaction. So what it implies, so what it means that half-life period for zero order reaction, it is directly proportional to its initial concentration. So from this formula, what you can see that, so T half of the reaction, okay, that is a half-life of the zero order reaction is directly proportional to the initial concentration of the reactant, and it is inversely proportional to the rate constant, right? So T half is directly proportional to the initial concentration, and it is inversely proportional to the what? It is inversely proportional to the rate constant. So these two are very important. Okay, so so by seeing the formula, you can see, right? By finding the initial this half life. Okay, so we have come to know that the half life of the zero order reaction, it is directly proportional to the initial concentration, and it is inversely proportional to the rate constant. So this is case one. Okay, in terms of your zero order reaction. So please note it down, very important. Yes, did you note it down? Okay, fine. So this was the case one where we have found out the T half of the that is the half-life period of the zero order reaction. So next is case two, where we are going to find the half-life period of half-life period for first order reaction. Okay, for first order reaction. Got it? So, very important. Mark this as important for 2 marks. So, a question can be asked. Derive the half-life period for first order reaction. Okay, don't get confused. The question can be either what? Read the questions properly. Okay, if they ask you derive the integrated rate equation, then you have to derive the first order reaction. Okay, if they ask you derive the half-life period, so you have to derive the half-life period. So what is the half-life period? Okay, so as we know, K is equals to first order reaction. What is the rate constant? That is 2.303 by T log of R naught by R, concentration of R. Okay, so therefore, what are the conditions? T is equals to T of half. Okay, and R will be taken as what? R is initial concentration, half of the initial concentration. So applying this, what we are going to get? Therefore, okay, so at time T, okay, at time T is equals to T half, R, that is your reactant is reduced to half of its initial concentration. So therefore, K is equals to 2.303 by T of half. Okay, then R naught by R naught by 2. R naught by 2. Okay. So K will be equal to, so K will be equal to 2.303 by T of half. Okay. So R naught and R naught get cancels. So it will be, so here it will be log of, okay, log of. So log of 2. So what is the log of 2? Log of 2 is, so find out log of 2, it is 0.3010. Okay, so K is equals to 2.303 by T of half into 0.30. So what we have to find? We have to find the T half. So T half, just transfer here. So 2.303 into 0.3010, how much it is coming? Just see. 2.303 into 0.3010. It is 0.693 by, okay, K. So this is your T half value, that is half-life period for first order. Okay, got it? Yes, is it clear? So half-life period. So taking the rate constant equation, okay, which we have derived from the integrated rate equation. Okay. So by taking that, applying the conditions where T is equals to T half. Okay, we are reducing the time. Okay, and we are that is when the time is reduced to half, and we have seen the concentration of the reactant is also reduced to its initial concentration. So by applying the conditions, okay, just cancel the common things, okay, and substitute the values, and you will get the answer. Okay, so so these also formulas you need to know for T half of zero order. So what is the zero order reaction? So zero order reaction, okay, T half for zero order is T half is equals to R naught by 2K. Okay, so this, and this is for first order. But mostly the questions will be asked from this particular, not from zero order. The problems and the derivation will be asked from for first order reaction. Okay, for the first order reaction. So what it implies now? So by this, what you can see, what you can tell that the half life of the first order reaction is independent of initial concentration of the reactant. Right? It is independent. It is not dependent here. In the zero order, you can see that it is dependent on the initial concentration of the reactant, but it is independent here. Okay, it is independent, and it is inversely proportional to the rate constant. So here also the half-life period is inversely proportional to the rate constant. Okay, is it clear? Okay, so this is with respect to the, I hope you have noted it down. Yes. Okay, so here are the important things. So what all we have seen now? Okay, so we have seen the T half. Okay, so we have seen the T half for the first order reaction and zero order reaction. So with respect to the nth fraction, so very important. Okay, this is for CET point of view. So for CET point of view, so for CET point of view, okay, so please note it down. Okay. So for first order reaction, okay, for first order reaction, okay, the time required, the time required for for nth fraction, for nth fraction of the reaction to complete is, okay. So when we want to find the time, okay, so for the first order reaction, when we are finding the time for the nth fraction of the reaction, nth means any number, okay. So how will be the T of half given as? So T of 1 by n, okay, T of 1 by n is equals to 2.303 by k, okay, log of 1 by 1 minus 1 by n. So this is the equation which is for the first order reaction when the time required for nth fraction of the reaction to complete the reaction. Okay, complete the reaction is okay. So this is the uh, first note you have to note down. Then second note is that what will be the half life period? Okay, half life period of reaction is related to order of reaction. Okay, so how the half-life period of this is reaction to order of reaction? It is T half is inversely proportional to A raised to n minus 1. Okay, A raised to n minus 1. So suppose for n is equals to 0. Suppose n is equals to 0, then T half will be what? T half will be directly, it is inversely proportional to A into what? Minus 1, right? Because n is equal will be 0. So T half will be, so if you, so it is directly proportional to A. So what it is? So T half of the reaction is directly proportional to the initial concentration for zero order reaction. Okay. So half-life period for zero order reaction is directly proportional to what? It is directly proportional to initial concentration. Okay. And if you take n is equals to 1, so in the same formula, if you put n is equals to 1 in this formula, okay, substitute and see. So it will be T half is inversely proportional to A into 1 minus 1. It is 0. So it is T half is directly proportional to 1. So A raised to 1 is 1. So half-life of the first order reaction is what? It is independent of initial concentration. So these things we have seen, right? So in zero order reaction, the T half of the system of the reaction, it is directly proportional to zero initial concentration. And for first order reaction, when n is equals to 1. That is for first order reaction, it is independent of the initial concentration. Now, what will happen if we take n is equals to 2? Okay, let us see with n is equals to 2. Let us see with n is equals to 2. N is equals to 2. Yes, substitute and see. So T half will be directly proportional to 1 by A into 2 minus 1. So T half is directly proportional to 1 by A raised to 1, right? A raised to 1. So half-life period for second order reaction is what? It is inversely proportional to its initial concentration. Okay, it is inversely proportional. It is not directly proportional. It is inversely proportional. Got it? Okay. So these are the important things you need to know. Is it clear up to here? So for first order reaction, when we are finding the time required for nth fraction of the reaction, it is given by T 1 by n is equals to 2.303 by k log of 1 by 1 minus 1 by n. So if we are finding the half-life period for how it is related to the order of the reaction, so T half it is, so how it is related? So T half is inversely proportional to A raised to n minus 1. So by substituting n is equals to 0, we see that the T half of the reaction is directly proportional to concentration of the initial concentration of the reactant. If we substitute T is equals n is equals to 1. Okay, what we can see, T half of the reaction, it is independent of the initial concentration. And when we see it, n is equals to 2, we can see that it is inversely proportional. T half period of the reaction is, it is inversely proportional to its initial concentration. Okay, so these are the important things. Okay, so let us solve some problems now. Let us solve some problems. So take the problem, first one. A first order reaction. Please note this important questions. A first order reaction is found to have a rate constant, that is k is equals to 5.5 into 10 raised to minus 14 per second. Okay. Find the half life of reaction. Okay. How to solve this? How to solve this? Yes. So for first order reaction, what is T half? So T half is equals to 0.693 by K. This is a formula, 2 marks problem again. This is a marks problem. Substitute and tell me the answer. Substitute and tell me the answer. We have to find the half-life period. Half-life is equals to 0.693 divided by 5.5 into 10 raised to minus 4 per second. Yes. What will be the answer? How much are you getting? 0.126. Okay. What about others? Okay. Lugna has also got it. Baby has also got it. Okay. Fine. So after substituting, so 0.693 by 5.5, it comes to 0.126 into, so 10 raised to minus 4 it is, sorry, 10 raised to minus 14 it is, okay. So make this correction, it is 10 raised to minus 14. 10 raised to minus 14. Okay. So after, if you transfer it above, it will be 10 raised to 14 because it is minus in the denominator. Okay. When it goes above, it will be 10 raised to 14. And per second it is, when it goes to the numerator, it will be second. So T half will be 0.126 into 10 raised to 14. Okay. So this is 10 raised to minus 14 second, not 4, minus 14 per second. Okay. Fine. So like this, the question is asked. So this is T half of the system. So 1 mark for the this and 1 mark for the answer with the correct units. Okay. Fine. Is it clear? Let us go for the next one. Yes. Shall we move for the next one?
Yes, ma'am.
Okay. So let us go for the next one. I hope you are making the notes. Okay. Fine. Next question. A first order A first order reaction has a half life of 45 minutes. How long will it take for 99.9% of the reaction to be completed? To be completed. Yes. So how you are going to solve this? How we are going to solve this? So for a first order reaction. So what is for a first order reaction? For first order reaction, it has a half-life of 45. So T half is given as 45 minutes. Okay. Then how long will it take for 99.9% of the reaction to be completed? So let us find first the order of reaction, that is for first order reaction. K is equals to 0.693 by T half, right? Because we have to find the rate constant. Okay, T half is given. So from this, what we will get? So 693 divided by 45. Just see how much you are getting. So 45 minutes, right? Okay. What is the answer you are getting? 0.693 divided by 45. Okay, BBS got it as 0.0154. Okay, correct. 0.0154. So this is minutes. When it goes in the numerator, it will become per minute. So this is your rate constant. So rate constant is what? K is equals to 0.0154 per minute. Now we have to find what? We have to find the this what for T is equals to 99.9%. Okay, so let us see the first order reaction. So K is equals to 2.303 by T, okay, log of A by A minus X. So what is that? So the our initial concentration will be what? Our initial concentration will be 100%. Okay. Then what is the number of moles consumed? The number of moles consumed is how much time it has taken? It is 99.9%. Okay. So what they have asked? They have asked the time taken for completing the 99.9% of the reaction. How much? Okay. So let us put this all conditions and let us find out the T half, that is T of, that is the time taken for 99.9%. So K will be equal to 2.303 by T of 99.9%. Okay, log of what is initial concentration? It is 100 and A minus X is 100 minus 99.9. Okay, so therefore, and what is K? We have got the K also, right? We have got the K also. So let us substitute the K value also here. So in the next step, I'll write. Okay, here I'll write in the next step. So K value is how much? It is, so what I can do, I'll transfer this here and I'll take this here. So it will be T of 99.9% is equals to 2.303 by K value is 0.0154. Okay, log of 100 by 100 minus 99.9. Okay, so just see, solve this. So 100, a log of 100 divided, sorry, 100 minus 99.9 is how much? It will be 100 minus 99.9 will be zero point 0.1. Okay, it will be zero point 0.1. So 2.303 by 0.0154 log of 100 by 0.1. So now see 100 divided by 0.1 is how much? It is 1000. So log of 1000. Okay. And what is 2.303? 2.303 divided by 0.0154. It is 149.54 into. So see what is log of 1000? Log of 1000 is 3. Log of 1000 is what? 3. So log of 1000 is 3. 3 into 3 into 3 into 149.54. Yes, 149.54. So how much are you getting answer? I have got it as 448.6 and it is T half, so it is per minute. Okay. This is unit is minute. Yes, baby has got it as 448. Yes. What about others? Others have got it. Yes. So I've got the time that is taken for 99.9% is 448.6 minute. Okay, important. Units are important. Everybody has got. Yes. So Bhagya, Sri Varuni has also got. Lubna has also got. Very good. Okay. What about others? Other Sharan, Yamuna. Yes. Did you all get? Okay. Fine. So, like this, the question is asked. Okay. So, did you understand? Yes. Did you understood it? So, did you note it down? Yes. So, problems, it won't be included in the notes. Okay. Okay. So, problems, I'm telling you, please note the problems. Okay. Very important. Fine. So, stepwise, write it properly. Okay. So, here only I have written the last one equation, or else it is like this only. So, go in a flow. First, I have found out the T half. Okay, T half of the system. And then I have found the, by applying these formulas. Okay, and then first here, second and third. Okay, and this is the fourth. Fine. Okay. Should I go for the next one? Okay. Let us go for the next one then. Show that, next question, show that, show that in a first order, in a first order reaction, time required, time required for completion of, for completion of 99.9% is 10 times of half-life of the reaction. So that is T half. What you have to show that T of 99.9% is equals to 10 into T of half. So what you have to show that 99.9% 10 times of half-life of the reaction. So this way you have to prove it. Okay, you have to prove it. So for first order reaction, okay, we know that for for first order reaction, okay. So for first order reaction, we know that T of half will be equals to 0.693 by K. This is our first equation. Okay, T half. Now what we know that the first rate constant is equals to 2.303 by T log of A by A minus X. Okay, so what are the conditions here? What are the conditions? That A is equals to 100. Again, X will be 99.9% and time is T of 99.9%. Okay, so now applying this in the above equation, what you'll get, we know that 2.303 by T is your T of half is your that is T of 99.9% is equals to, right? So here it will be your K. This is your K. The log of A by A minus X, we have seen it is 1000. Okay. So that is T of 99.9% is equals to 2.303 by K. What is log of this? Log of this is 3. Okay, so this is equation 2. Now, okay, so we have found out what is T of 99.9% also and what is T of half. So T of half is what? T of half is 0.693 that we have derived and we have got this also. Now what we can do next step, divide 2 by 1. Okay, we have to prove, what we have to prove, that T of 99.9% is 10 times of T of half. So this we have to prove. So let us see. Okay, so that we are proving. So divide 2 by 1. So T of 99.9% is equals to 2.303 by K into 3. Okay, and T of half is nothing but 50%. So I'll write it as 50%, T of 50%. Okay, so 0.693 is equals to 0.693. So let me write this properly systematically. So this is 2.303 into 3 divided by K. Okay, so K, no, I have done. So now what are the similar things? So K get cancels. Okay, so 2.303. So 2.303 into 3. 2.303 into 3 is 6.909 divided by 0.693. Divided by 0.693. It is coming to be 9.969. Okay. And what is so so it is T of 99.9%. So what I'll do this now, which is in the denominator, let me transfer it here. Okay, so what it will become into T of 50%. So 9.9 is nothing but approx to 10, right? It is approx to 10. So T of 99.9% is equal to, it is 10 times of T of 50%. Is it clear? Not showing here. Let me show it here. 99.9% by T of 50%. So what we have done, we have shifted this T50 on the here. Okay. Got it? Yes. Is it clear?
Yes, ma'am.
Yes. Okay. So please note it down. So they have asked what? Show that in a first order reaction, what is the time taken for completion of 99.9% in which is 10 times of half life of the reaction. Okay. So that you have to show. Okay. So is it clear? Did you note it down? Okay, so there are three more questions. Okay, so let us take one more question. Consider a reaction A giving you products, okay, with rate constant value as 2.0 into 10 raised to minus 2 per second. Calculate the concentration of A remaining after 100 seconds. Okay, if the initial concentration of A is 1 mole per liter. Okay, so another question based on the first order reaction. So one more question based on the first order reaction. So for first order reaction, okay. So what is this K is equals to 2.303 by T log of R naught by R. Okay, concentration of R. So what is considered a reaction A giving you products with rate constant is 2 point into 10 raised to minus 2 per second. Okay, so for a concentration of A remaining after 100 second, if the initial concentration of A is 1. So what all is given? Rate constant value is given, that is 2 into 10 raised to minus 2. Okay, per second is equals to 2.303. What is time taken? 100 seconds. Okay, then log of what is the initial concentration? The initial concentration is 1 mole. Okay, it is 1 mole. And we have to find the concentration, how much has been remaining after 100 seconds. So let us write it as R. So what we'll do? So 2.30, or sorry, 2. So 2.0 into 10 raised to minus 2. Okay, so 100, let us transfer it here. So it will be 100. So this will go in the denominator. So 2.303 is equals to log of log of 1 by concentration of R. Okay. So 100 and 10 raised to minus 2. So this will get cancelled. Okay. 100 and 10 raised to minus 2. So this will get cancelled. Minus 2 divided by, you see how much you're getting? 2 divided by 2.303. So it is 0.8684. Are you getting the same? Is equals to log of 1 by concentration of R. So let us take, so what we are doing now, we are going to shift this and a log on the other side. So this becomes anti-log. So anti-log of 0.8684 is equals to 1 by concentration of R. So that is 1 by concentration of R is equals to, what is the anti-log of 0.8684? Yes. So log tables will be given for the exams. Okay. So what you have to do, how to take the anti-log? So you have to raise the logarithm, okay, of base b, that is usually okay, and so that is log of 5 is x. So anti-log, so if it is log of 5, okay, if you have to find log of 5 is x, then its anti-log will be 10 raised to x. Okay, so you have to raise its power to x. So what is anti-log? So how much you have got? 0.86. Okay, that was the previous one. Okay, we just find out our anti-log. So, so if log of y is equals to x, okay, then y will be equal to anti-log of x, right? So first you have to divide the this into characteristic part and mantissa part, right? So the whole part, it is the whole part. So this is the, what is whole part? So 0.8684. So if you want to calculate the anti-log of that, so how you have to take 0.8684. So I've got the value of anti-log here as, so 1 by R, okay, 1 by R is equals to 7.386. I've got it as find out, okay. So find out, practice the anti-logarithms. So how to take the anti-logarithm? So it will be this. So R is equals to 1 by 7.386. So the concentration of R will be 0.135 mole per liter. So this is the answer I'm getting. So please note it down. Note down the answers and find out how to get the anti-logs. Okay. Homework for you. How to find the anti-logs? Okay, anti-log. So in the exam, logarithm books will be given. So by using that, you can solve. Okay, fine. So is it clear? So we have seen how many problems? So we have seen one, two, three, four problems, and initially I had solved one problem. So five problems we have done. Okay. So two more problems. So let us do that two problems in the next class. Okay. Any doubts up to here? Yes, all the problems are clear.
Yes, ma'am.
Okay, fine. So any other doubts? So anti-logs, just try to find today how to find the anti-log. Okay. And see the answer, write down the answers, remaining steps. Okay. And see whether you are getting the same or fine. Okay. So I hope whatever the things are told in today's class, it is understood. Okay. So the remaining things we will discuss it in the next class. Okay. So I hope all your doubts are clear. Okay. Fine. So I shall end the session here. We'll meet in tomorrow's class. Thank you. Have a good day.